You have been for some chair.
For someone?
For some hustles.
I was just finishing up with something here outside. Yes.
Okay.
There are no hustles. Maybe if you have connections, man, there.
Eh?
The hustles are very few here. I don't know if you have if you have some.
Yeah, with time it's going to be there. Let's just keep in touch.
So
With
for
time,
now, what should we be doing now? For now, what should we be doing?
For now.
We'll be doing what? As we wait.
As we wait, so tell me what you want to do.
And everyone will be saying it will come, it will come.
Yeah, of course it will come, but of course when it comes, of course, so how can you teach? Can you teach software? Of course, if there's opportunity which comes around, I may leave. Then you'll be the one to teach students. I saw you want to teach. I teach you. Then you teach students.
Which software?
Even this one you are going to teach. If I told you are to do so, AutoCAD and ArchCAD.
Yeah, those ones I can teach very well.
Okay.
I've been training some guys at campus though. You know, time just could just catch us and we just don't finish.
Okay. So if at all you are to teaching them, how much are you going to charge me? If I'm to bring you here, how much are you going to charge me?
For which entity, which softwares?
For teaching, and you are going to teach all the
software.
Per
software or all of them?
All of them, not one.
It depends on how many students there will be.
Auntie, what will you ask for? What will you ask? Because remember, I'll prepare for you what to teach. And you'll also, I'll be there to guide you in case you wanted to know something. I'll guide you. You understand?
And you're meaning like seriously, or you just estimating?
Yeah, I can't tell you that I'm serious, but you know, sometimes I get busy. And you know, okay, like if at all, you say I have different sessions here.
Yeah.
And sometimes they collide, is it? You see, I have another student also one who is coming to join for Tekla, and the person cannot be with you.
Yeah, we'll be at different levels.
For you have gone ahead. So again, that one needs to be scheduled another time.
So you're the only one teaching in Jarib?
I teach, okay, for all the civil softwares, I'm the one teaching. The other guy teaches electrical and the mechanical.
Maps, yeah?
He teaches maps. They teach maps.
After I'm also running those ones, I'm also finishing up with those.
Okay.
With map, yeah.
Then you can if you learn, you can also come teach them. Like we cut the other line, then you can come in.
Yeah, me I can help you even if now I can help you on those guys of AutoCAD and ArchCAD.
Okay.
Although this one I can't lie to you because we are still moving.
Yes.
I guarantee you is if it is anything dealing with ArchCAD or AutoCAD.
Still in AutoCAD, I have done some things which I can show you because I have some plugins here
Oh.
I don't know whether Eurocode is having plugins.
No, not really.
Yes, then if it means if it's to be so, I can show you the plugins and you know.
There's that YQ arch, eh?
That YQ arch. Then there's one also, there's another plugin for auto rebar.
Auto rebar, yeah.
Uh,
I remember I tried using YQ arch, but I don't know where I stopped with it. But
no,
sometime back.
so nice. YQ is YQ arch. If you know the formulas, you know, moving through the tools, it's very hard. But if you have captured the formulas,
Yeah,
the shortcuts, it's very, very quick.
very fast.
Because it does for you, even it does for you elevations, it does for you sections. You understand? It's really good. Yes. So, how much do you think you can charge if at all you are to do so?
And I'm still confused on what exactly is required of me. Then I know how to charge.
It's okay now if you first think about it, and you know we are here. You'll get time and come to the office and we talk.
But okay. But maybe the other week. Next week I want to travel to Mbarara.
Mbarara, it's okay now. When you come back, we shall discuss about it.
Yeah, okay.
Yes.
I think by then we will be also, and actually it is also good after running this Tekla and then you start teaching it because you master a lot of things.
Yes, you now be teaching them those things. Also,
As
you do
you master.
the practical bit, like you can even design. When it works there, you design, and you know something like that.
Yeah.
I'll show you like how to do a complete design, and you know that's how it is.
All right.
That's why here the office is just. You say you're in what Kanyanya Mpere?
You see, I had your near Komambo. Is it Komambo?
Komamboga, just here we are here.
Actually, I was staying in Komamboga sometime back. There, is it Kumukaga? You know that road?
Hey.
Actually, see, you know Digida, where Digida is?
What?
That place for poker there in Komamboga, called Digida.
Yeah, I know Komamboga there, that side.
So near that place.
Hey. No, we are not reached Komamboga. We're just here in Chitala. Chitala, just here. This Komamboga Road.
Around Gayaza.
Just here, you know, Palm Gardens around here. Just here, yeah.
Okay.
You search if you search the name of the company online, it will show you where it is.
Is that power disappearing? Do you have power?
I have power.
These guys of UD here.
But it has just come like some 20 minutes ago.
But for us, we've been with it now. It has just disappeared right now.
And this power.
But me, I have what? I have some power to push me. So I think we can just start and then see how to.
It is okay. Let me first fix my PC properly.
All right.
Okay. Let me take you briefly in less than 10 minutes.
About the column,
columns. Okay. It, To talk about column, if we have we have a column. Let me say this is our column. This is our column. Let me say this is the first floor. This is the second floor. Okay. And this is now a G plus 2 structure. This is a G plus 2 structure. Let me say it's going 3 meters, 3 meters, and also 3 meters. Okay. Now, for you to calculate for the column sizing, like for you to calculate for preliminary, iPhone. Okay, to calculate for
the size
of column, you come here. It's calculated from this formula. It's calculated from this formula of the NED. The NED is the axial load on column. NED. So it'll be equals to what?
Equals or less or equal.
It's less or equals to. Let me just put like that. NED should be less or equal to.
Greater or equal. That is a design load.
Yeah, it should be greater. It should be
greater or equal.
Greater or equals to, yeah. Greater or equals to 0.85 FYK over over 1.5 area of what? Area of concrete plus and write this up here. Plus FYD plus FYD area of steel. Okay? Of which FYD, that's right. Of which, FYD equals to CK divided by 1.15. Okay? Design yield strength of a steel is given by FCK divided by 1.15. Okay? You get that?
Yeah.
So, area of what? Area of steel, yes. That is how it ends. NED equals to 0.85 FYK over 1.5. 1.5 is the partial factor of safety of concrete. Then apply by area of concrete plus FYD area of steel. Okay? So, you have written the formula.
Yeah.
So now, At this case, your Eurocode is saying that you consider, if you, of course, you have not done the loading, you have not calculated the loading on each flow, okay? Each loading, loading being carried by each column on each floor. You have to assume that is the NED at this point. The NED assumed. You have to assume your NED should be between 12 kilonewton per square meter to 15 kilonewton per square meter. Okay? So at this point, you have to assume your NED is between 12 to 15. Okay? Yes. That is the first thing you have to consider. Then, thereafter, you need to calculate considering this NED comprises of the slab load, the finishes, the life load, and whole load, including even for the beam. So you assume this NED is composed of all the loadings from different structures, structural members. Okay? You understand?
Yeah.
Yes. So from that point, you now calculate the total loading for this column, like what this column carries. Okay? So your total loading T, the total loading TL is calculated from how many columns are here? There are 3 columns, okay? You understand? Multiply by you also assume, like, you know, as I said, if we have column like this, like, let me say, if this is a slab, and maybe we have, let me say, if we take this one to be a critical column, like this is a critical column like this, okay? Yeah. So this is the load it carries, okay? So this is the load the column carries. So the load being carried by the column is in form of what? Areas, okay? It's a cubic area. It's like the length and the width, okay? So we are saying, let's assume the load being carried by this column, the area, the total area of the load being carried by this column, let's assume it to be 15 meters squared, okay? You're assuming, you're just assuming. That value is very clear. Maybe you can say this is the length from here to here. Maybe you're saying it's carrying 4 meters. This is also 4 meters. You're calculating can be like 16. So let's take 15 to be the tributary areas. Okay? Yes, if we take let me say 16, of course. Let's take this one to be 2 meters. I mean, from here to here, it is 4 meters. From here to here, it is 4 meters. Okay? So halfway, if you half, it's going to be like 2 meters, 2 meters, 2 meters, 2 meters. Okay? So it's going to be 16. So let's take it to be 16. Okay? So the total load carried by this column is going to be the total height, like the total length of the column is going to be each column, which is 3 meters, is going to carry what? The loading of what? Of 15 kilonewtons. You understand?
16, eh?
I mean 16, let's consider 16. Okay? I think I call. So, okay, excuse me, we continue. I was saying, yes? Next one.
Hey, yes, I had waited. It's okay.
Okay. I was saying, we are saying each flow carries what? Each flow carries 15. Each flow that we assume each flow carries what? Wolf. Okay. It carries wolf kilonewton. The NED, the loading on each column. Okay. Be 12 kilonewton. Then multiplied by the tributary area, the one we calculate here, we calculated here, which is 16. Okay. Understand? Then multiply by how many columns are there? There are 1, 2, 3. Okay. Then multiply by 3. What are you having? I'm having 576.
Mm. 576.
Yeah. 576. This is in kilonewtons. Okay. Understand? Kilonewton. The reason as to why it is in kilonewton is because this 16 it was in square meter, and this one was in kilonewtons per square. So square cancels, it remains in kilonewton. Okay.
Yeah.
Yes. Now that we have 576 kilonewtons, okay. You convert this value.
Wait, the three was meters. Eh?
No, 3 is meters. 3 is what the number of columns you have.
Going upwards, eh?
Going upwards, yeah. 1, 2, 3.
Oh, the number, not the height, eh?
Yeah?
Is it? It's just the number, not the height.
No, it's just number. 1, 2, 3 columns.
3. Okay.
Yes. So now that we have this value of NED in kilonewtons,
that is what total load or NED? Total load.
The total load, okay? Okay. Now you need to factor this load, okay? You need to factor this load. To factor this load of NED, you need to multiply this loading by 1.5. Okay? You need to multiply this by 1.5. We're going to have 576. Okay? You multiply that load by 1.5, 1.5 multiplied 576. We're having 864. We're going to have 864 kilonewtons. Okay? Yes. Now that you have 864 kilonewtons, okay? 864 kilonewtons, 864 kilonewtons. Okay? Now that you have 864 kilonewtons, 864 kilonewtons, 864 kilonewtons. Okay? Yes. Now that you have 864 kilonewtons, 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 864 kilon
So that NED of 1.5 times that one, is it a formula or what?
Which one? No, now remember the load you had, it was just a normal load, unfactored load, okay? So you factor it, you're adding, you're now accounting for those loadings which are not catered for. So you factor it by 1.5, okay? So when you factor it by 1.5, you're going to get 864 kilonewtons, okay? Now you convert this one into newtons, okay? Yeah. If you convert this into newtons, multiply by what? Kilonewton to newton, you multiply by 1,000 or 10,000?
1,000.
1,000, yeah. So you're going to have 864,000 newtons. Okay? This is now your NET. Okay? Yes. Now that you have that value, you go to your formula. You know, you know from pressure equals to force over area. You know this, eh? Okay. Now let's go to our formula that we are having. The formula we had it was NED. NED. Your NED should be greater or equals to, this value you are seeing here should be greater or equals to 0.85 multiplied by 0.85 multiplied by FYK. Considering use of FYK, like using FYK of the FYK that we are using, let's consider it to be 25, okay? 25 Newton per square millimeters, okay? So let's consider FYK to be 25 Newton per millimeters multiplied by the area of concrete, which is not given, then to be divided by 0. I mean, it is 1.5. 1.5. 1.5. Okay? Then plus FYQ. FYD. What is FYD? Let me actually.
FCK over.
FYD.
What is FCK?
FCK. FCK. Okay. FCK is going to be 25. FCK is going to be 25. That's all.
FCK. What's FCK is what?
The thing is, in the formula we are having 1% somewhere here. You understand? In the formula, there's 1% as if, yeah, there's 1%.
1%.
1%. Yes. The formula there's 1%.
FCK of 1%.
Let me get for you the real formula, the password. You get the real formula. That's 1%. Guy has 1%. Wait. Let's sample this as oh, 1%. Is it? No, it's not having. This one is another different one. Okay, it's not having. So it's FYD. It's FYD array of still. Okay. What is FYD? FYD is equal to FYK. FCK divided by 1.15. Not so?
AS.
Yeah?
AS.
AS?
AS is not there.
ASC. I mean AS, yeah, AS is there. 1.5 multiplied by AS. Now, for column, we are using column of we are using column of T16. We are using 4 T16. We're using 4 T16. You know area. You know getting area of column. The diameter of the bar we are using is 16 squared to be divided by 4. You understand this? You know that getting area of a circle is pi d squared. Pi d squared divided by 4. You understand? The diameter of the bar that we are using is 16. Okay. But we are using 4 of them. 4. You understand that?
4 of them.
4 T16 in a column. Like if this is a column, we have 4 of them. 1 here, 2 here, 3 here, 4 here. Okay? There are 4. So you calculate the area for this 4. That's why I'm having 4 multiplied by pi. This is pi. 4 multiplied by pi multiplied by 16 squared divided by 4. Okay?
Yeah. That the other FCK imposes what?
FCK is 25.
No, like what is its description?
FCK is the compressive strength of the compressive strength of concrete. The FCK, the compressive strength of concrete for in 28 days, like the strength of concrete in 28 days after curing. Okay. Yes. You understand?
Yeah.
Yes. So when you calculate this is 0.85 multiplied by 25 divided by 1.5. I'm having 0.85 multiplied by 25 divided by 1.5. I'm having 14.16 here. Okay. So let you have written this thing,
Yeah.
Okay, now let me delete this and I write the things directly here. So here I'm getting 14.16. 14.16 multiplied by the area of concrete. The area of weight is the area of the thing of the area. I mean area of the column. The area of the column that we want. Yeah. Area of the concrete AC. Then you add it to this one. So this one, let me also get the calculations for this. Let me clear this.
But I think we are looking for FYD.
No, we are not looking. We are looking for AC. AC.
No, I'm meaning like the one which we are from calculating that one of 14.16.
Yeah.
Was it FYD or FYK?
It is the FY. It is the
FYD. Is it FYD?
FYD is for this one. FYD is for this one. This one is FYD. This is it. FCD.
Yeah.
This is the FCD.
FCD.
FCD. Yeah. FCD. Let me give you the difference.
FCD or FCK?
And no, not FCK. It's FCD. It's like this way you see here. Okay. FCD. The FCD, the compressive design strength, FCD is given by 0.85. Actually, yeah, 0.85 FCK divided by the Pascal factor of safety of concrete. Okay, that is the formula for FCD. Okay. Then FYD, of which 0.85 we calculated and got this thing. Then we have to multiply with the area of column. Okay.
So we are calculating for FCD.
We are calculating for AC. We want AC, which is the column section.
No, I'm meaning the one which we are from calculating, that 14.16. This area, that formula which has area AS.
AS is here. AS.
That one.
This one. This is for FYD.
FYD. But you're putting it in place of FYK. You're putting it in place of FYK.
FYK. Are you sure?
That formula where you're saying that is it 864,000 newtons to be greater or equal?
This one. This one is small. This value, this side is worst, it's small. It's less than it will be less than any ED. Okay. Okay.
Which formula is that? Which formula? That formula which you're putting in, which you're taking back that 14.16. Which formula is that? Which one are you relating?
Okay, the formula.
I thought you were doing NED to be greater or equal to 0. That formula, that first formula.
Okay, and it is the one. It's the one. Oh, you have forgotten. Let me first. How can I show you first?
That formula, I have it
here.
That formula, I have it here. That first formula.
You have it, no, sir?
Yeah, NED to be greater or equal 0.85 FYK AC.
Divided by 1.5, no, sir?
Then plus FYD AS.
That is it. That is it. So we have 0.85, no, sir? Then I say that we should use FYK No, it's not FYK, it's FCK. It is FCK, not FYK. 0.85 FCK. Okay?
FCK.
Yeah, 0.85 FCK.
Yeah, that's what was confusing now.
Whereby FCK is 25. Eh?
FCK is 25.
Then divide by 1.5. What are you having if you have a calculator?
I don't have a calculator.
Yeah, you are having 14.16. Okay? 14.16, then multiply by SC. You get that? Then you come to this other, which is FYD AS. Whereby FYD equals to FYK is equals to FCK over 1.15. Okay? Understand?
Yes.
AS. No, FAS is separate. So I'm just trying to break FYD. Yeah, and that AS is there already. So AS, for you to calculate AS is pi D squared over 4. Okay? Yeah, that's why you're seeing I'm using 4T16. Then diameter 16 divided by 4. You understand that? Okay?
Yeah. So what is FYD? What is FYD? 25 over. What is the answer from that formula, that last formula on your screen?
I'm having 17483.
174?
83. 17483.6. Okay, you can just put it to a whole number 17483. What 84?
It is in what? It
is in millimeters.
Okay.
It is 17484. 84. Okay. So now we have this 14 plus 1, 6 multiplied by area of concrete plus 17484. Okay. So now this one, you subtract this value of 1784 from 864000. Okay. 64000 minus answer. I'm having that value. Then I divide the answer by 14.6. 14.16. Okay. So if I divide the answer by 14, so now I have 14.1 AC equals to what? Equals to 84 6, 5, 1.35. Not so? Yes. So if I divide this value by 14, if I divide by 14.16, if I divide by 14.16, I will have your AC. Your AC is going to be 597.882 square millimeters. Okay? Yes. Now, now this is the area. So how can I get the base and the BD? How can I get this one? BD under root, okay? So it's going to be under the root of the area, which is a 59782. Okay? So UB multiplied by D is going to be, so you get the root of this answer. The root of answer. I'm having 244.5. 245, let me say. 245 millimeters. Okay?
First come back from that square root, how you introduce those square root. The area you read the area at BBD, B by D.
B by D, you know, area is like, okay, let me say, you know, area is gotten by B times D. Okay. So this is area squared. Okay. Is it first way? Not area squared, I mean, this is area. Okay. So you know area is gotten by B multiplied by this. So this answer is square. So you introduce what? You introduce a root. You introduce a root here, you also introduce a root here. So this so when you introduce a root here, this is already a square. It cancels this root, you're going to remain with the B and D. B multiplied by D. Okay? So you get a root of this answer. Okay?
That A is squared.
Area is equals to B multiplied by D. You know that?
Yeah.
So if you know B multiplied by D is equals to area, okay? B multiplied by D is equals to area, then you introduce a root here, you also introduce a root here. So if you introduce root on both sides, you come and square this root. You come and square this root here, okay? Now, if this root you're seeing here, if it goes the other side, it's going to what? Put this one into a half, okay? Understand? So root squared, if a root, you know this mark, the root squared cancel this. You understand? Yes, it cancel that. So when it cancels this, you're going to remain with it. You're just going to remain with the B multiplied by D. Then the cube root, and the square root of this, and the root. You put the root of that value. Okay. If you put the root, you are going to get 544.5.
5.
So you are going to get this answer.
245.
So it means your column width is your column breadth and depth is going to be 245 by 245. Okay. So you see that the value is not so common. We just take 250 by 250. So we say by this. Now let me later take 250 by 250. Okay? Look at that column. If you try it, you may find it can just pass. You understand? You just find it passes. As simple as that. So, any question, first ask me before we go to the load calculation. Then we open it.
Before we go to?
We go to how to calculate the loading that we can put it in Tekla. I wanted us to load the Tekla that structure. I wanted us to load it today.
So if this thing has to be calculated like this always, or what?
And that one you also calculate it. You also calculate it. Hey,
I mean this because should it be that a column has to always be a square?
No, you just calculate. You only calculate for dead load. You don't calculate for live load. Live load, you just go to Eurocode, you get it. For dead load, it's very simple. You calculate for dead load, you just calculate the weight of the. Remember, the self weight of the beam will be taken by the software. The slam load is also going to be taken by the software. So for you just calculate the wall loading only.
The wall?
The wall loading, yeah. You like, let me first show you a sample here. You have written this thing, eh?
Yeah.
Yes. Okay. Now let me say if you have your frame like this, you have a frame like this. So let me say this is the ground floor, this is the ground floor, this is the ground floor. And then we have this is the first floor, this is the roof. Okay. Yeah. So if you are to remember, since this is the ground floor, you'll be having wall here. You have a wall here. But remember, this wall for it, it's not going to be carried. This wall is not going to be carried, just sitting direct to the ground beam, or maybe on the soil straight away. This one you don't consider it. So what we are looking at is the loading. I mean, the load being carried by the column from up. The wall load, how the wall can safely transfer the load how the column can safely transfer the load of the wall into the ground floor, actually into the foundation. So now that we have this is the column and this is our beam. So now we have our wall. We have this wall. This is our wall. The one we are going to calculate the loading for. Okay? Yes, we are going to take this one. Only this. Of which it's this beam to carry the load and take to the columns on both sides. Okay? So if we have something like that, and let me say, let me draw with this. If we have a, let me say this is our column, okay? If this is our column, and we have this is it. Let me take this guy. It's right here. It has a beam down, it has a beam up. Okay? Yeah, let me take it like this. So it has a beam. So let me say we are using a beam of 400, a beam of 400. We are using a beam of 400 by 200. Okay? You understand? So just say we have this, you know, beam. This is how beam drops. Okay? You understand? So let's say our wall height like this. We have a wall height of 3 meters. Okay? So the wall height we are considering, which is being carried by this ground beam here, you see, I mean this downward beam, is the height from here up to here. Okay? Remember, this beam is already part. This beam has gone like this. So this beam is already part of this floor. This beam is part of this floor, part of this floor. Okay? So for you to calculate the height of the wall being carried by this, let me say H. Okay? For you to calculate the height of the wall being carried by this beam is gotten from H equals to the total wall height is 3 meters. You deduct the depth of the beam, which is dropping here. The beam is 200, the thickness is 200 by 400. So you come and deduct here 0.4. Okay? So you're going to have 2.6 meters. Okay? It means the weight being carried by this beam down here is going to be, we are now calculating from this, let me delete this now. So for us to calculate now, the GK of wall, is calculated from the thickness of the wall multiplied by the height of the wall, then multiplied by the unity weight, and this is U, the unity weight of wall. Okay? Whereby the unit weight of wall, like let me say the normal wall, that the normal bricks, this is the unit weight of brick, I mean, not wall. This is the unit weight of brick. The unit weight of brick, the common brick that we are using, the unit weight iterates from 16 kilonewton per cubic meter to 22. Okay? Yeah, so you can choose depending on the one you like. So me, I'm choosing like using this concrete bricks. Yeah, unit weight is 20. So I come, the wall thickness is the same as the thickness of the what? Of the beam, which is 100, okay? So 200 millimeters, I come and say the thickness of the wall is the same as the one for the beam, 0.2 multiplied by the wall height, which is from here up to here, which is what? 2.6, 2.6, then multiplied by the unit weight of brick, which is 20, the one I use, okay? So when you calculate this, you have 0.2 multiplied by 2.6 multiplied by 20. I'm having 10.4. 10.4 kilonewtons. Okay, this one is in the meters, this is also in the meters. So remember this 20 is in the kilonewton per cubic meter, so it reduces this one to kilonewton per meter, okay? So this is the GK that we're going to use in the software. Put it down, 10.4. 10.4 kilonewton per meter. Okay? Yes, now we are done calculating. Let's go to the software. I mean, let's go to on the software, let's go to the Eurocode and get QK now. Because we need both GK and QK. QK, you can get it from Eurocode just in 1 minute.
I'm saying, my question earlier was about this, that sizing of the column we got. B by D. So you see, we got B by D to be equals 250 both. So how do you get when the depth is not the same as the B?
Like,
because you see, we got 250 by 250. So now, right, let's say like now the column which you're using here in an example is 400 by 200.
400 by 200.
So
now, that one, okay. The column I'm using maybe says 400 by 200. Now you see those columns like 400 by 200. Do you know why they are used and how they are used? Those columns they are used. Let me first give you some scenario like this. You have written this thing down, eh? You know, when you're constructing, you also consider neatness. And if you look at a column of 200 by 400, number one, the person is trying to dodge the what? Like this is your wall, and this is your wall. Okay. So this is a wall, also this is a wall, so this is a wall, and also this is a wall. So if you have to see columns like 200 and 400, they are placed in a way that it should not have a funny shapes protruding outside. Okay? If you're using column 400 by 200, normally you may find the 200 is the thickness of the wall. So they're just trying to align it. They are, for example, 400 by 200, you may find they are putting it here. They are putting it here. They are putting here, 200 by 400. Okay? Even here, they can put the 400 by 200 here. I'm answering you in that way. They're going to put it here to prevent those bad looks, like, for example, now, if you're using 200 by 200 and your column comes up to here, okay? Remember, your wall has stopped there. Your wall has also stopped there. So they are using if this preliminary member sizing, it helps you to know the size of the column you should use. Now, if you have, remember, you are doing the preliminary sizing without knowing the size of the column, okay? So now, you consider using this kind of column where need arises. You understand? You consider using this one where need arises. Now you can see, for example, you have a long stretch maybe, let me say 5 meters. Between here and here is 5 meters, okay? So when you look at 5 meters and you have a column of 250 by 250, you put 250 by 250 here, like here, and also 250 by 250 here. It's exactly where it means now the span of the beam is very, very long, very long. And if you're to look at this, it's exactly at the end point, at like where these two meet, there's no overlap. So you will look into use of a column which has at least a large surface area to hold the point load from the beam. So you'll come and decide on the use of a rectangular column whereby at least it will have, like, remember here you are having 200. So at least this protruding end here, first of all, it will be inside the wall. Secondly, it will at least reduce the point load on the small column. Also this side, it will reduce the point load on the column. You understand? Yes. So at least this one now, it has a wider surface to carry load from here. It has a wider surface to carry load from this end of the beam, and also it has a wider surface to carry up to here. So this one, it easily distributes, it easily carries load from different beams. Okay? You understand?
Yeah.
Yes. So some things there you just ask me before I continue.
No, it's okay now.
So we have that. Let me take you the software, the Tekla guy. I had a software called Tekla Structure. I found that I've deleted it, man. I've just seen that I've deleted Tekla Structure.
Yeah. How?
Just seen it. Yeah, it is some heavy software, but it is very, very good, man. I've just seen it.
You just deleted or uninstalled?
No, I uninstalled. I didn't know. I was trying to, that day when I wanted to install this software, I found that I was uninstalled the other one. I'm installing 24 for this one. So let's have a building of, this is ground floor, this is first floor, second floor, then the roof. Okay.
Okay.
Then we have this is our foundation. Then this is our ground floor. We have ground floor. Then we have this is the first floor. This is the second floor. And this is the roof level. Okay? Then let's have this guy to be -1 because it's going in a negative direction. So let's have wall height 3.
Why also start we move together in the software? Or?
I had this. I'm going to. This is recorded already. The video is recorded already.
Okay.
You are seeing it. Now, for you who has been practicing, this one is just you just pick something.
Yeah.
So I wanted us to finish at least 10 minutes past 10, past 9. So you have, I wanted this one to replicate 2, okay? I wanted the first floor to replicate 2. Even the roof floor to replicate this, but I'll change for the roof floor. So I want on the roof, I want a slab of 100. Here I'm going to use a slab of 200. We calculated it last time. Also 200. Okay? Understand? Yes. I think you can still remind us with the beam depth we calculated last time. You have it.
The beam what?
The beam depth, the size of the beam that we calculated for last time.
We had 350? The
Okay,
H.
let me first reach there and then we continue now.
The section was 200 by 350.
Okay. Let me first go to next. Let me set the grid. So we are having here we are going to have maybe 1, 2, 3. Let me use the spacing of 4. Let me use spacing of 4.
Make something irregular.
Irregular. So you make something irregular, like for example, let me start with the 5 meters. Let me start with the 5, 4.5, 5,
3,
3. Okay, let me have something like that. 1, 2, 3, 4. Something like that. Yeah, that is so good. We have this next. Here, let me say I have 1.5. That is the first. Let me say second. I have 4. I have 4. I have 1.5. It's like a building which has a front here and a front the other side. Say next, finish. So this is what I have. Okay. So I go to column. Okay. Then when I reach column, I change, I run to the properties. The concrete class I'm using is 2530. Then I come down here, the column section. We are using 250 by 250. 250 by 250. Okay. Come and check. Let me change this one to 30. The concrete cover, nominal cover. Let's have it 30. And then automatic alignment. This one you always have to check it. Okay. Now when you reach here, you just click up there and drag here. It's for you the column. Okay. Yes, you put in the 3D and see. You have the column, you rotate it like this. Okay? Yes, click escape. Now, You don't draw beam from here. You right click and go to open with first floor. Not even ground, you go to first floor. Okay? So that's what you see from the first floor. Okay? So I come to beam. So I'm using, let me come here. You come, you leave this one, rotational, you leave nominal. Concrete cap is normal. You change the concrete class 2530. You drop down, then you have sections. You come, click here, okay? Section. You have a beam of 200 by
350.
100 by 350. This is going to fail, but it is okay. At least as we know it. Then you leave major element here. It is being aligned from top. Check here. Yes. We have it.
Automatic alignment, you leave it.
Eh?
Automatic alignment.
No, for that one you only uncheck for
columns.
For column. But for this one you just leave it. Okay? Then even here you highlight there, you drag it down. S. You have your, you put in 3D and check. You have everything. Okay? You see? You see how easy Tekla is?
Yeah.
Very, very easy and very, very quick. Yes. Now, remember this guy here is the roof. And this guy down here. And this one is carrying normal loading. So this is a ring beam. This ring beam is carrying a roof load. So you consider it to be the roof load. For that matter, you go to construction level and what? And change it to be unique, such that you won't have the same slab settings. Okay? You go to first floor. Then you go to slab on beam. You first click. You escape it. You go to slab. Then you go to slab on beams. You come here, you override the slab depth. Then we got slab depth to be 200. Then you drop down here. You change the slab, the overall depth be 200. Then you check, you change this one to 25, 30. It's cover. Then you click up there, you drag down. You understand? You check in 3D, you have everything. Is it okay?
Okay.
Any question? Any question?
No.
Okay. You go there. Then I want to go to the roof. You say you open with the roof level. I click there. You understand? I go to slab on beam. And I count the slab depth. Now for the beam, you can leave it 100. You want to come and change the concrete class. You change it to 530. You understand? You put it there. When you come to 3D, you now have everything. Okay? Okay? You now have everything. Then now you have drawn your thing like this. You come here. You click validate. Okay? So if you have this, come and check why is it. Check loading. No, empty load cases. No. This one, your validation is okay. The moment you see, if you have seen this, it means it is showing you that you have not done something. this one is still okay. But if you have seen XX, it means you have a point which is not connected somewhere. You need to go and what?
Connect.
You need to go and work on it. You extend it. You remove. You either remove and put it again, or you extend if you can. Okay. Yes. Here. Now we are ready to do our loading. So I said we have our GK. We got it. We got our. We have gotten it as 10.4. Is it 10.4? Yeah, kilonewton. Okay. You need to find the QK. For us to find the QK, you come to what? Come to Eurocode. Let me take you to. Okay. So let me say this is a. Yeah, you got Eurocode 1, 1991. 1991. 1991. Action on structure. So you come to page 21. This is for free. Let me go up. Page 21. Yes. Yes, page 21 is here. Okay. You have ever seen this table?
Yeah.
Yes, table 6.1 is talking about the loading of what? Of structures. We have different categories of structures. We have structure of category A, category B, category C, and category D. Okay? Yes. Category A is saying the category A is for areas for domestic and residential activities. So it means if you are designing for a structure which is going to be for residential activities, like where people live, where just like homes, that is under category A. So they're saying, example, rooms in residential buildings and houses, bedroom and wards in the hospital, bedrooms in the hotels and hostels, kitchens and toilet. Okay. So we are designing for what? For residential buildings. For that matter, your residential building is under category what? Category A. So you use table 6.1 in conjunction with what? Table 6.2. So you come and pick category A, then you scroll down to table 6.2. So if you reach table 6.2, you come under category A. Okay? When you come under category A, what are you loading? What are you loading? Are you loading floors? Are you loading stairs, balconies? Remember, if you are loading a slab is under floor. Okay? Slab is under floor. Even staircase is under floor. So you come to floors and check the what? The loading. So they are saying for floors, the loading has to be between 1.5 to 2. Okay? He's saying it has to be between 1.5 to 2. So it has aligned, they have aligned 2. They have underlined 2. It means 2 is the what? Is the maximum. I mean the what? The worst condition case. The worst condition case is 2 kilonewton per square meter. So it means for residential, they have said that the worst condition for residential building and all loading of floors, it has to be 2 kilonewtons. Okay. So this is the what the axle loading. You don't consider this. The QK, this kilonewton, this one. Of course, we don't consider this one being spread over meter. Okay, this is distributed. This is like point load. Okay, this is like point load. So this is it. Since it has been distributed over a specified area, you consider what this one. So for Q, it means our QK, you come and select 2. Come and select 2 kilonewtons per square meter. Okay? You now have QK and GK. Now, also you have to consider the roof. The roof loading is also what? Is a life load. The roof loading is a life load. And the roof loading, it caters for, actually, the ring beam caters for the loading of a beam, of a roof. Okay, so the slab you have placed at the top roof is considered to be what? To be the loading of the roof. Okay? So for that, hope I'm not fast.
No.
So for that matter, you come to roof loading. This categories of storage. This is industrial area storage. This is flows, industrial area flows for roof. You come down here. This is traffic parking areas. For roof now, categorization of roofs. They are saying categories of loaded area, specific use number 1. We have roof of category H. They're saying roofs not acceptable. I mean roofs not accessible except for normal maintenance and repair. Okay, like those which are not accessible, you can't climb there like at your will just to go and play around there. Like our normal roof, like our bungalow roof, you can't go there unless it's a repair. So they lie under what? Category H. Okay. Have a roof I. They are saying roofs accessible with occupancy according to categories A to AC1, G, AC1. Okay. So now these are this one. They are those roofs, for example, on apartments where people can have their rooftops, their pergolas, they can chat around. You understand? Those roofs where people can sit and chat up there. So they are treated under I. Okay? There's category K. This one is what? The roofs accessible for special services such as helicopter landing areas. Now, these roofs are those ones where even helicopters can land. Now, these are the roofs, for example, you can have a, what? The swimming pool up. You understand? Those are the kind of roofs. But for us, ours is lying under category H, which is not accessible. So you come down here, they are saying impose load on roof. Okay? You come, they are saying where say H, not 1. For category H, QK may be selected within the range of 0.0 kilonewton to 1. Okay? And QK may be, we didn't know, this one not 1. Yes, we are here, between 0.0 kilonewton to 1. So it means our value of Q, remember, we can't select 0 because we have the loading from what? From the iron sheet, the pallets, the timber, you know, yeah. So, on my calculation, I found out that the loading for that roof is, you can take 0.7, 0.6, 0.7, 0.8 there, okay? In that case, let's take the GK for roof, I mean, the QK for roof to be 7.5 kilonewtons per square meter. Okay? Then let's go back to the software. Hope you have understood.
The QK, was it for the roof or for the last one?
There are two QKs. There is a QK for the floors and the QK for roof.
For the floor, the one which was from 1.5 to 2.
Yeah. So the one expected to be 2 kilonewton is for the floor. Then they say between 0 to 1 is for roof. Okay? Whereby I've decided to use 0.75.
Okay.
0.75 is the one I've chosen. Okay? So for that, I'm now coming to the loading. Let me finish loading and you stop there. Okay? Now, loading. So before you start doing the loading, you come and check down here. You are having none. Okay? There's no loading on this. So you come under none, you select which loading do you want to do first. Okay? You understand?
Yeah.
The self-weight is already taken by the software. The self-weight of the column, the beam slab is already taken. Okay? So now let me take what I'm going to put. Even the service load, this service load is going to be filled when we are calculating for the what? When we are doing combination, it's going to come automatic. What we're going to add there is the imposed load and dead load. Okay? Imposed load. You click on imposed load. So if you click on imposed load, you come to load up. You have seen load. Yes? You have seen load.
Yeah.
So I click on load. Okay? So now, since you're loading a flow, and it is a flow has a leveled surface. Okay, so for that case, you either load a level load or understand? You either load a slab load or a level load. For that matter, let's take a level load. So we are loading a level load. Okay. Then you come to this table, the load table. Are you with me?
Yeah.
You come to level load to load QK, which is the imposed load. The QK we have gotten for the level, for the flow is 2. Okay? Not so?
Yes.
Yes. Now you have a QK of 2. You zoom and just put it on the slab. Okay? You understand? Yeah, that is the QK you have put for the slab. That is it. You can see it from there. Now I come back to the loading. I change this one to what? To 0.75. Now this is the loading of the roof. Okay? Now that's why I had to make it unique. So I put it here. You can even see 0.75. Each loading is very small. Okay? Yes, then I can click escape. So if I come back here, I put none, the loading disappears. I go back to imposed load. You can see we have our imposed load. If you put your cursor there, it's going to show for you the loading on the story 2, which is the first floor. It's having a load of 2 kilonewton. The direction of the loading is what? Is global Z. The global Z is what? It is an axial load. It's from up, it's a gravity load from up coming down. Okay? Then you also come and put on this. It's saying now the load on the story 3, which is the second floor, is 2 kilonewton per square meter. It's also a global load. and no global Z. You can also put here, you check. You understand? That's how you load it. You load a live load or impose the load. You understand? Then now you go to first flow, which is down there. Now I'm going to load it. The dead load, which is the GK. Okay. Now
the GK.
GK. The first one we loaded was QK. Okay.
Yeah.
Now we're loading GK, the wall load. The loading, you know, since it is GK and it is the wall load, for it runs over the beam. It runs over the beam. Now, if you can see here, if you click on the wall, sometimes you can have what interference from the slab. So for this matter, you need to turn off the slab. If you turn off the slab, you can easily load your wall on the beam. So you come this thing here. There is this window of scene content. You have seen scene content here. When you go to scene content, you come and say slab item. You turn it off. Slab item. You uncheck that box. Then slab goes off. You will be remaining with what? You will be remaining with
Beams
alone. So you come here, down here, you now change to dead load. You change to dead, okay? Now when you change to dead, now this dead load is what is a full UDL. It's a uniformly distributed load. So you come here and click on full UDL. You understand? Click on full UDL, then you come and change this loading to 10.4. Okay? Then you put it exactly where the wall passes. If there's a balcony, you don't load it there. Remember, on balconies, there are no walls running around. So you just put it exactly where walls passes. Okay? You come and start looking. You can see this front part is a balcony, even this one is a balcony. So I just load this. This where walls pass. I load this. I load this. I load this one. I load this. I load this. You just click on it. Just click on it. When you see green, just know it's loaded. When you see green, just know it's loaded. Just click there. We are loading something like that, okay? Then after that, you click escape. Understand?
Yeah.
Then you go to 3D. We had this command of impose the load on the 3D. So you come and change to none. Okay? Let's put our dead load. You click on dead load, you see? You see our loading is there already. You understand?
Yeah.
Our loading is there already. Okay? Are you seeing?
Yeah.
Are you understanding something?
Yeah.
Yes. So after loading like this, you come and click on validate to check. Yes, we have modeled everything. On that we have empty load case. Okay, we have empty load case, you leave it now. Empty load case now. Can we stop here?
I think it is okay. Because for the loading for the loading of the walls, after activating the load here down, you just go up there on full UDL.
Full UDL, yeah, you go on full UDL.
Then for the floors, you activate the load down, and then go to load.
And then go to
load, the other load.
Impose the load, and the other side you go to load, then you load what? Level load. Level load, okay? Yes.
Oh, I get now.
Something like that.
Okay.
It's okay. So tomorrow, not tomorrow, and tomorrow is Sunday. Yeah. And so I know when I say tomorrow, I know you're going to remind me tomorrow. So tomorrow is Sunday. You know, I have to be. Actually, we are not supposed to even do the thing today. But of course, no. Since I promised you today, yesterday we have to do something today. Then of course, I never wanted to lie to my promise. Yes. So on Monday, I don't know, but on Monday I need to have a lecture with those guys of AutoCAD. That is online at this time.
That's online.
So how we should fix yours? Can we fix? How can we fix yours?
Maybe we can see if we can do afternoon.
Afternoon, yeah, I'm looking at that. Doing it after, you know, man, afternoon we should not take long because man, it affects me for the evening thing. Let me just a content, the strong one like this. Like me say if we are to take 2 hours, okay? This is the major thing. If we are done modeling, you know how to model. Yeah, okay?
Yeah.
So I wanted you to follow exactly what we have done today. Then tomorrow, I want you to send me your work.
Tomorrow, eh?
Tomorrow. Okay. Tomorrow or Monday. I think tomorrow, no, not tomorrow, leave tomorrow, man. Don't touch my weekend. Don't touch it. Okay, on Monday.
You want the what? The file or the what?
No, I want you to draw for me something. Okay, you model for me something like this and you load it. Okay?
And I'm asking how do you want it? Because you want to see the file or the what?
I want a file. I want a file. Of course, from the file I can check the loading you have done. Of course, I can also check those sections, element, your members. So please, I wanted you to actually use the same. Okay, you can assume this, but I want you to come up with a structure like this. Okay, then you write this down. Lessons that we have used. I wanted whether our things are going to be the same. This is the 5 meters. This one is 24. This is a 5 meters. Then this is a 3. Okay. You write that one down. Then this side we have 1.5. And this side.
Just give me back the first one.
The upper one.
4.5, 5, and 3.
Yes.
Then the other one is 1.
No, 1.5. 4. And again 1.5.
For 2 times, eh?
For 2 times, yeah. I wanted it to come with something like this.
So the columns are how many? What by what?
You have there 250 by 250.
Okay.
Then the beam is 200 by 350.
Okay.
The slab for the first floor and the second floor should be 200 millimeters thick. Then the one for the roof has to be 100, and also for the ground floor should be 100. Okay.
For the ground floor.
You just leave, of course, you leave it, but of course, from the setting there, construction level, for the second, you can have 100. But of course, you don't put down there. You understand? So I wanted you to come up with something like this, and we see.
All right.
This is the assignment I've given you. In case of anything, you can wait for Monday and put down or you can send me message on my WhatsApp, and the message you are going to send me should be the one which will not force me to open the computer on the weekends. Send me a message which will not make me open my PC when I'm in weekend mood.
It's all right. It's all right.
It's okay, it's okay, it's okay. You can send me. I can. I'm there. I'm just joking.
Mm.
So you can send me anything, and and we learn something. And this is so good. I wanted you to produce something like this, and okay.
If you wanted, I can even give you tonight, but I would give you on Monday.
Now give me on Monday, not tonight.
All right, Kai.
Yes, yes, yes. And now,
Mm.
you can. Yeah, you have my email because I asked you to send me things like yeah, assignment. Then you send it on email.
On email.
Yes.
I think when you get time, you will send me the email on my phone, on WhatsApp.
I'm going to say it now. So the assignment is it in on email. Okay.
Mm.
Okay, okay, okay. Thank you. So how was it? How was today's session?
It was also good.
Hmm.
It was also informative.
What is it that you have not understood, or where you want to have some more clarifications and what?
Not really, not really.
Okay.
Mm.
Oh, that's so good. Thanks for attending and thanks for paying a lot of attention. So wish to meet on Monday again.
All right, all right. Good night.
Good night.